Hi everyone, this is Joe from Healing Math Trauma. In my last middle school video, I talked about how tape diagrams can be a really powerful tool to help middle school students understand percent problems. Today, I'm going to talk about how tape diagrams can be incredibly powerful in helping middle school students understand the structure of algebraic equations and really see how different types of equations can be solved in different ways.
These equations look really similar, and anyone who has taught middle schoolers knows that it is super common for kids to start with the equation on the left here, and their first step is to turn it into the equation on the right, even though these two equations are not the same and they are fundamentally structurally different. So, what I'm going to talk about today is how we can use tape diagrams to really help kids understand the fundamental differences between these two similar equations. I'm going to start with the equation on the right and show how that can be represented and then actually solved using a tape diagram. So the first thing we're going to do is declare this entire space to be 10. And now in the equation, we have 2x plus 4 equals 10. So the 10 has been split up into one part that's 2x and another part that's 4. So that altogether it's 2x plus 4 gives us a total of 10. Well, when I have it split up like that, it's not too hard for me to see that this 2x part over here has to be 6 because 6 and 4 together give me 10. So that means I can make another tape diagram where the total now is 6. And now I'm saying, okay, I have two unknown pieces that together are giving me 6. And so here's my 2x together that's giving me 6. And I can now see that, well, I need to take that 6 and to divide it into two even pieces. So each of those pieces is going to have to be 3. So I can see here that x equals 3. Now, if we contrast that to the blue equation on the left over here, I'm again going to start with a total of 10. But now I want to think carefully about what the equation is actually telling me. When I have 2 and then in parentheses x plus 4, that's saying 2 times x plus 4. So there are really two separate copies of x plus 4 that give me 10. So this is saying this should be split up into two even pieces, and each of those pieces should be represented by x plus 4. Well, when I see something that is a total of 10 getting split up into two even pieces, I know that each of those pieces has to be 5. So now I can write another tape diagram where I can say now the whole thing is 5 and it's split up into an x piece and a 4 piece. And so I'll call this part 4 and this part x. And then I can see pretty clearly that that x is going to have to be 1, so that the whole part right here adds up to 5. So here x equals 1. Now, this is just sort of walking through how I would use a tape diagram to find the solutions in these two different equations, but I think it's also helpful to dig a little bit deeper and to see how the tape diagram can really help us fundamentally understand the structural differences between this equation and that equation, and how that can, if we sort of dive even deeper into these two different tape diagrams, how we can use the tape diagrams to understand those differences. To really understand how the tape diagram can help us see the different structures between these two equations more clearly, we can break them apart even further. So if I start with this equation on the right here, right now I have it broken up into 2x and 4, but I could break this up even further, still maintaining the whole of 10. And I can say, okay, here this part is 4, and then I'm going to break it up into two unknown pieces, x and x, versus the one on the left. Right now it's broken up into two copies of x plus 4, but each of those two copies can be further broken up into an x part and a 4 part. And so you wouldn't necessarily need to break it up this much and in quite this way if you were using a tape diagram as a tool to find the solution to the equation. But I think it can be demonstrative now to help us really understand how these two equations are fundamentally structurally different, right? I can see in this one on the left how because it's 2 times the quantity of x plus 4, I've got two x's and two copies of 4. So I can see the distributive property, how this is really x plus 4 plus x plus 4, which is 2x plus 8. And all of that is being equal to 10. Versus on the right here, I see that I still have the two copies of x, but now I have only one copy of 4, and so it's just 2x plus 4 equals 10. Also, if you try to do this a little bit to scale, it can make sense that the value of x in the equation on the right is going to be larger than the one in the equation on the left. Um, I think it's just a really important tool to help kids understand that these two equations are fundamentally built differently. And I also like this because I think sometimes kids see equations that have parentheses and they think that they have to distribute. And now there's nothing wrong with distributing as a first step and seeing how, okay, sure, I can turn it into 2x plus 8 equals 10, and then I'll be subtracting 8 as my next step. And that's definitely mathematically correct. However, by writing it out using a tape diagram, we can kind of see the structure that might kind of hint at the fact that a good first step might be, rather than distributing, might be to divide both sides by 2. And so we can see that x plus 4 is equal to 5. Um, and I think the tape diagram helps illuminate that structure and that particular solution pathway a little bit more clearly.
Thank you so much for watching. As always, if you have any questions, please hit me up in the comments. I would love to answer any questions or any follow-up ideas that you may have after watching this video.